This video is to illustrate an example of finding the area of the region between curves, and I'm going to do this one two different ways. I'm going to do it with respect to x, and then I'm going to do it with respect to y, just so you can see the difference between the two. So we're going to find the area of the region bounded by y equal to 10 over x, y equal to 2, y equal to 10, and x equal to 0. So I've gone ahead and drawn the region, found the points of intersection like we all know how to do, and there is my region there. So if I do this with respect to x, every one of my rectangles are going to need to be vertical. Now what you notice is that if my rectangles are vertical, I'm going to have to split this into two different regions, because I have this region here, which basically is a rectangle, where every one of my rectangles start up there at y equal to 10, and they end down there at y equal to 2. So the length of all the rectangles in that region, since they go from y equal to 10 to y equal to 2, the length of every one of those rectangles there is 8. So for that first piece there, I'm going to have to integrate just a constant, which I'm going to have to integrate 8. And I know it's a rectangle, so we could just find the area of that region, but I want to do it with integration just so you see where you have to split up the two different pieces. And then in my other region here, every one of my rectangles in this region, they start up here at x comma, and then my y values are 10 over x, and they end down here at x comma 2. So the length of every one of those rectangles are going to be the distance from 10 over, which is going to be 10 over x minus 2. So every one of those rectangles are 10 over x minus 2, and then every one of the rectangles over here are 10 minus 2, which we know to be 8. So I'm going to have to split it into those two different regions, and my bounds for my integration also are extremely important here. So everything here is with respect to x. So if I do everything with respect to x, then I have to split that area into two different regions. So I have my first region. My first region in my picture there, so I'm going to do a lot of scrolling back and forth, so I apologize in advance for that. But my first region here, like I said, every one of my rectangles are going to have the same length of 8, and my bounds are going to go from 0 over to where I have to split my region, which is over there at x equal to 1. So I'm going to integrate from 0 to 1 of 8 dx plus, and then my second region is going to go from 1 over to where it ends, which is over there at 5. So I'm going to go from 1 to 5, and the length of every one of the rectangles in that region is 10 over x minus 2, all that dx. And then, again, that's probably the hardest part, is trying to get everything set up. But notice the key is you have to split that into two different regions, because if you're doing it with respect to x and you draw your rectangles don't have all the same length, so you have to split that into two different pieces. So be careful about that. Okay, so if I integrate that with respect to x, this is not the hard part here. If we integrate 8, we get 8x that we're going to evaluate from 0 to 1. And again, that was a geometric shape, so I could have just done the base, which is 1, times the height, which is 8, and gotten that answer that way. But I wanted you to see where the integration came in. And then over here, if I integrate 10 over x, that's going to be 10 times the natural log of the absolute value of x minus 2x, and we evaluate that from 1 to 5. So if we take off and we plug in our numbers, I'm not going to spend a whole lot of time on this. This is not the hard part. If I plug in 1, I'm going to have 8, and then minus 0, so I'm just going to have 8, like we said. Plus, if I plug in 5, this is going to be 10 times the natural log of 5. Don't need the absolute value more. Minus 2 times 5, which is 10. And then be careful with your signs here, but it's going to be minus 10 times the natural log of 1. And then since it's a minus and already a negative, it's going to turn into a plus, and then 2 times 1 is going to give me 2. Okay, so now just add everything together here. We have an 8 and a 2, which gives us a positive 10, and then we have a negative 10, so those cancel. And then I have 10 times the natural log of 5, and then the natural log of 1 is 0, so that goes away. And so what I'm left with is just 10 times the natural log of 5 for my final answer. And if you want a decimal approximation, you can pull out your calculator and get a decimal approximation. Okay. That was with respect to x. And again, the main thing that I wanted you to see doing that with respect to x is I wanted you to see that we had to split that into two different pieces. So now, if you'll allow me just a second, I need to get my screen back here. So now if I take that same problem and I do this now with respect to y. So if I do this with respect to y, so I'm going to turn every one of my rectangles horizontally. If I turn my rectangles horizontally, then you'll notice that I won't have to split this into two different pieces. So be careful when you get to a problem. You want to look and make sure you look at it both ways and see which way may be easier than one way, and also it depends on your equations and different things. But if I'm going to do this with respect to y, then I need to get everything that I have up there in my problem in terms of y. So I have y equal to 2 and y equal to 10. X equals 0 is a vertical line, so that's not going to be a big deal. So the only piece I'm going to have to fix is this y equal to 10 over x. So if I take that equation and I cross multiply or multiply through by x, I get x times y is equal to 10. And so again, we're trying to get everything in terms of y. So if I solve that for x, I get x is equal to 10 over y. So every one of these rectangles here, they end over here at 0 comma some y value. They start over there, sorry, at 0 comma some y value, and they end over here at x, which I just found to be 10 over y, comma some y value. So the length of every one of those rectangles, which are turned horizontally, go from 10 over y to 0. So the length of every one of those rectangles is just 10 over y. So now, if I turn them all horizontally and I integrate this with respect to y, I don't have to split that into two different pieces. I can just keep it in one region. And now I have the length of every one of my rectangles there. So the area of my region here is going to be the area, and I'm going to integrate. Now be careful, because now we're integrating with respect to y. So if we come back here and look at our picture, look vertically, every one of the rectangles, I would start here at 2 and end up there at 10 if I stack those rectangles on top of each other. So I'm going to integrate from 2 to 10 of the length of every one of those rectangles, which is 10 over y, all that dy. So if we integrate that, that's going to be 10 times the natural log of the absolute value of y, evaluated from 2 to 10. And so if we plug in our numbers, we get 10 times the natural log of 10 minus 10 times the natural log of 2. Now we should get the same answer, whether we do it vertically with respect to x or horizontally with respect to y, in terms of our rectangles. And so I should get 10 times the natural log of 5. And you can see that these are equivalent with just a couple of steps. But if we factor out the 10, then what I'm left with is the natural log of 10 minus the natural log of 2. If I factor out that 10, and then use my properties of logarithms, and this is 10 times, put that back together as one single logarithm with a division, which would be 10 divided by 2, and we have the same answer, which is 10 times the natural log of 5. So I hope that that example illustrates the two different techniques that you have to find the area between curves. You can either do it vertically, which means everything with respect to x in terms of your rectangles. Horizontally, everything is with respect to y, and that you notice when you have to split it, when you don't have to split it, and sometimes one way may be easier than the other. Neither one of those were extremely challenging, but one way may be a lot easier than the other way, so make sure you pay attention to your orientation and that you look at both ways to see which way might be easier.